Hey everyone, this is Lesson 2, an introduction to limits and graphical limits. You should have your pink Calculus Unit 1 packet, and you should be taking notes on pages 6 through 8 during this video. So let's start by talking about your learning targets. We have 3 separate learning targets for today. I can write a limit statement using correct notation that references a given function. I can estimate a one-sided or two-sided limit given the graph of a function, and I can justify why a limit does not exist at a point using limit statements when necessary. So by the end of this video, you should have at least a little bit of an understanding of what each of these learning targets represents so that you can start to then be able to do it all on your own. So let's start by quickly recapping what we did in the Desmos activity with the with the piecewise functions review. So we're going to take a look at these 3 separate piecewise graphs, and we're going to find f of 2 for each of them. So what that means is find the x value, 2, and figure out which y value the function has. So in the first graph, we've got a closed circle right here at 4. And you'll notice that this piecewise graph is just simply 2 separate line segments connected at x equals 2. In the second one, we also have 2 separate line segments, but now they're not connected at 2, it's actually broken. But we're still going to look for that closed circle, and we can see that that function value is 4. And in the last graph, we can see it's just this line with a hole, and the function value is removed. So x equals 2, find the closed circle. For the function value, it's also x equals 4. So although f of 2 equals 4 for all of the functions shown in the graphs above, each of the graphs looks very different, right? It's 2 separate line segments connected, or it's 2 separate line segments that are broken, or it's one line with a hole that's been removed. So what we need then is we need a better way to describe the behavior of a function near the particular x value, rather than just depending on the function value. By knowing the function value, that's great. It's a great piece of information, but it's not enough to give me a clear picture of what the graph actually looks like. We can have an infinite number of graphs where f of 2 equals 4, and the graphs could be completely different from each other. So if we start by looking at the limits, then we can figure out what's happening around that function value in addition to what the function value actually is. So a limit is the y value that a function approaches as x approaches a specific number. In other words, a limit tells us where the function intends to go. So pretty much the limit is like, hey, it looks like the function value is going to be this. Whether or not it actually is irrelevant. It just means that this is what the graph looks like it's heading towards. So we've got this limit notation here. You're going to want to be super familiar with this. And what we say is the limit of f of x as x approaches c is L. So we're going to break that down just super quick and talk about a couple of different pieces here. So you'll notice right here is that c. That's the x value that we're getting really close to. So this c is just some arbitrary x value that we pick. So as we get closer and closer to this particular value, this c, we want to know what the function is doing. And so we can see this L that's here, that's our limit, that's our y value. So that's right here. And then the only other thing I want to point out just really quickly is that, I need a different color here, there we go. This f of x right here is just the function that we're talking about. So whatever the function happens to be, that's our f of x. So you'll want to know those different pieces as we continue talking about limits and about correct limit notation. So let's take a look here at these one-sided limits first. So for the left-sided limit, you'll notice, take a look at this limit notation down here first. The limit of f of x as x approaches 2 from the left. The way that we symbolize that is by putting this little minus sign up at the top here. So a left-sided limit means that we need to put that little minus sign. So let's talk about what this actually means. So here's the line x equals 2. And when you look at it, we have a left side and a right side. Since I want the left-sided limit, what that means is I want to look at what's happening as I approach 2 from the left. So from the left side, it means I'm looking at this piece over here. And I can see that this looks like it's heading towards 4. So that's my left-sided limit there. Then we have a right-sided limit. Take a look at the notation for a right-sided limit. The limit of f of x as x approaches 2 from the right, we simply just put that little plus sign up at the top of the 2 instead to show that we're looking from the right side. So again, if we draw that line at x equals 2, and you don't have to do this, I'm just trying to give you guys a visual of where the left and the right side part is coming from. So again, left side, right side. I want to know what's the function doing as I approach 2 from the right side. So, wow, that just did that on its own. That was cool. Sorry about that. We're approaching from the right side, so we're looking here. That right-sided limit is 5. So even though that's an open circle, that's our limit, all right? You have to remember that a function value and a limit are not necessarily going to be the same value. The limit simply tells us what it looks like the function value is going to be, not necessarily what it is. So you'll notice for the left-sided limit on this graph, that was the function value at 2. However, for the right-sided limit, 5 is not the function value, but it is the limit. All right, so we also have two-sided limits, right? So we can look at the left side, the right side, or we can look at both sides. So we write the limit of f of x as x approaches c, and you'll notice there's nothing on that c value. So it means we're just looking at both sides. A two-sided limit only exists if the limit of f of x as x approaches c from the left is equal to the limit of f of x as x approaches c from the right. So in other words, the left limit has to equal the right limit. Technically, I should be calling it the right-sided and left-sided. But the left and the right have to equal each other or the limit does not exist. So let's look at these two separate situations here. I'm going to go ahead and draw in the line at x equals 2. So we're looking at the limit of f of x as x approaches 2. Since there's no plus or minus sign there, we know that this means we're looking at a two-sided limit. So what colors did I use here? Green and purple. Okay. So let's look at that left limit. So from the left side, as we approach 2, it looks like, let's go ahead and write our limit notation. So the limit as x approaches 2 from the left of f of x, it looks like the function is heading towards 3. So there's our left-sided limit. Now let's look at the right-sided limit. So we're going to do the limit as x, or I'm sorry, the limit of f of x as x approaches 2 from the right side. So if we look at the function and we approach 2 from the right side, it also looks like we're heading towards 3. Since the left side and the right side are equal to each other, the overall limit is actually 3. So we're good to go. Let's do the same thing for this next example. If you don't need to draw this line at x equals 2, that's totally fine. I just find that it helps at least in the beginning. So let's do the left-sided limit first. So the limit of f of x, oops, I don't know what that was. Limit of f of x as x approaches 2 from the left side. So if we look at the left piece of this piecewise, we're looking at this portion down here. It looks like the function is heading towards 4. So that means the left-sided limit is 4. Now if we look at the limit as x approaches, the limit of f of x as x approaches 2 from the right side, we're looking at the top portion of this piecewise graph, and that right-sided limit is 5. The left limit is 4 and the right limit is 5. That means this two-sided limit that we're looking at here, because remember there's nothing written here, so this is a two-sided limit. That means this limit does not exist. And the reason for that is because the limit of f of x as x approaches 2 from the left is not equal to the limit of f of x as x approaches 2 from the right. So when we looked at the green portion, it was 4. The purple portion was 5. Because those are not the same, the overall limit does not exist. And I know that it is a lot to write, but this entire thing is what needs to be written. If you think back to those learning targets that we talked about up at the very top, this last learning target is I can justify why a limit does not exist at a point using limit statements. That's what this is talking about. So you have to be able to show me that you know the limit does not exist and justify why with correct limit notation. Okay, so now we've got this graph with lots of different pieces to it, and we're going to find a bunch of different limits together. So for the first one, it says the limit as x approaches -4 from the left of f of x. So, no, the limit of f of x as x approaches -4 from the left. Sorry, I say that backwards a lot. Please correct me if you ever catch me doing it. So if we're looking at x equals -4, I'm going to draw in this line just for this first one so we can really get a good visual of this. We want to approach -4 from the left side. So we're going to be approaching from this side here. We can see the function is approaching a y value of 0. And then I'm going to erase that there. Now we're looking at the limit of f of x as x approaches -4 from the right. So now we're going to be looking at this other side. So from the right of -4, what does it look like the function is approaching? It's approaching 0. Number 3, the limit of f of x as x approaches -4. Since there's no plus or minus here, we know that this is talking about our two-sided limit, which means we need to look at the left and at the right. And if we do that, and we did it in questions 1 and 2 anyway, but we can see that both the left limit and the right limit are approaching 0, so the overall limit is also 0. I'm going to erase this so it doesn't get in our way of the other problems that we're going to do. Okay, now we're looking at the limit of f of x as x approaches -2 from the left. So -2 is right here. I want to approach -2 from the left side, so I'm looking over here. That is a y value of 2. Limit of f of x as x approaches -2 from the right side, so now I'm going to be looking down here. That one is approaching 0. And now for number 6, I'm looking at that two-sided limit again. Since the left limit is 2 and the right limit is 0, this limit does not exist. So we need to use the proper notation. So this limit does not exist, and this is because, and I'm going to move down here a little bit so I have more space to write it, the limit of f of x as x approaches -2 from the left does not equal the limit of f of x as x approaches -2 from the right. So again, we can look, there's a huge break in this graph here when we look. So from one side it's heading up to 2, from the other side it's heading to 0. That means the overall limit does not exist because they are not equal to each other. All right, now we're looking at an x value of 4. So let's go up here. And actually, we have an asymptote at x equals 4. Oh, maybe blue wasn't a good choice. Let's do red. So we have an asymptote at x equals 4. Let's see how that affects our limit values. So for number 7, we're looking at the limit of f of x as x approaches 4 from the left side. So on the left side, we're looking at this portion of the graph here, and we can see that that is heading down. That's going down to -infinity. We're almost looking at the end behavior then. The limit of f of x as x approaches 4 from the right, that means we're looking at this portion of the graph, and we can see that's heading up to +infinity. So if we look at the overall limit, again, if we take a look at the graph, we can clearly see from the left and the right, it's not approaching the same thing. And we did that. We also did the evaluation already. From the left, it's -infinity. From the right, it's +infinity. So hopefully that means you can already tell me this limit does not exist because this is where you're going to get all your practice with your limit notation. The limit of f of x as x approaches 4 from the left does not equal the limit of f of x as x approaches 4 from the right. So the overall limit does not exist. All right, I'm going to go erase some of this stuff on the graph so that we can mark it up again. Oops, that wasn't what I wanted to do. There we go. No, I don't want it to erase all of that. Sorry, I'm still working on all this, guys, figuring it all out, the best way to get it done. So bear with me for a second. Sorry about that. Okay. Let's take a look at number 10 then. So for number 10, it's the limit of f of x as x approaches 1. You'll notice this is a two-sided limit, and we didn't find the one-sided limits already. So we are going to have to do that. So take a look at the graph at x equals 1. So let's see here. It looks like each of these tick marks is a half, which means x equals 1 is right here. I'm going to just draw in this dotted line here. This is x equals 1. So I want the overall limit as x approaches 1, which means I need to look at the left limit and the right limit. So from the left side, over here, it looks like it's approaching 1. From the right side, it also looks like it's approaching 1, which means my overall limit is 1. Now I'm going to look at the limit of f of x as x approaches infinity. So as x gets bigger and bigger, what's happening to my function values? So let's look over here. We can see x values are getting bigger as we go this direction. So what's happening to the y values? We can see this right here is approaching a horizontal asymptote at 0, which means my limit as x approaches infinity must be 0. Hopefully that made sense. I know I kind of just seems like that randomly came out of nowhere. But if we're looking at as x gets bigger and bigger, we can see that this is going to continue going this direction. And so that y value, that function value it's approaching, is actually 0. And the last question, the limit of f of x as x approaches negative infinity. So we're going to be looking at the other side of the graph then. We're looking at what's going on with this piece. As the x values get more and more negative, as they get bigger and bigger in the negative direction, this function value is heading off this way. That's going to be heading off eventually to positive infinity. So these last two numbers, 11 and 12, are really looking at the end behaviors of the function. What's happening as x gets infinitely big, and what's happening as x gets infinitely big in the negative direction. All right, hopefully that made sense. If you guys have questions, please make sure you wrote them down, and we will talk about them in class. I'll see you later. Thanks for watching.